Most calendar systems are built on two fundamental units: the year, based on the time it takes for the Earth to orbit the Sun, and the month, based on the time it takes for the Moon to orbit the Earth. But because 12 lunar months is too short to fill a year, and 13 months is too long, calendars have to use weird workarounds to make it fit. The Gregorian calendar just takes a year and divides it into 12 sections, meaning the phases of the moon drift from month to month, while the Islamic calendar just defines a year as 12 lunar months, meaning the seasons drift from year to year. And in lunisolar calendars, like the Chinese or Hebrew or Hindu calendar, the number of months has to vary from year to year, so some years are substantially longer than others. But what if, instead of having 12 or 13 months of roughly 4 weeks each, we divide the year into 4 seasons of 13 weeks each? Doing this comes much closer to the exact length of a year than either 12 or 13 lunar cycles, and it presents a fun design opportunity. Instead of just numbering the weeks 1 through 13 and calling it a day, you can number them to 10 and name the rest the Jack, Queen, and King weeks. Oh, and the first one is the Ace week for good measure. Then, for the names of the seasons, because autumn, winter, spring, and summer happen at different times in different places, and in some places don't happen at all, I'll use symbolic names for each, though, if you're in the northern hemisphere, you can remember that autumn is the season of spades, which look like fallen leaves. Winter is the season of diamonds, representing the crystalline nature of snow. Spring is the season of clubs, as is when flowers and mosses grow back, and summer is the season of hearts, to symbolize the warmth of love. And for the southern hemisphere, spring is spades, as it's the time to shovel the fields for seeds. Summer is diamonds, which shine bright like the sun. Autumn is clubs, which look like fallen leaves, and winter is hearts, for the love needed to endure the cold. However you split it, with 7 days in a week, 13 weeks in a season, and 4 seasons in a year, we get 364 days in total, meaning we just need to add a leap week or joker week every 5.5 years, or twice every 11 years. Having a multiple of 11 here actually works out well for 2 reasons. One, it aligns the calendar to the sunspot cycle, which peaks roughly every 11 years, or maybe 10.7? In all honesty, the irregularity of the sunspot cycle makes this a terrible basis for any calendar, so... 2. If I instead say there's 4 jokers every 22 years, I can number the decks 0 through 21, and give each a name from the major arcana, putting jokers in the deck of the Fool, the deck of the Hierophant, the deck of Strength, and the deck of the Tower. All 22 decks together make 1 shoe, and, as a final rule, the deck of the Fool and every 10th shoe will have a joker removed, keeping the calendar aligned to drift only 1 day every 793 years. Which isn't as good as the Gregorian calendar, but it is better than the Julian calendar, though because the basis of this card calendar is the week rather than the day, the next adjustment won't be needed for over 5,000 years. So, yeah, that's the card calendar. There's a few other notes I want to make about the design of this, though. Like, I specifically decided to put the jokers at the end of the year, with the next year starting close to the September equinox, because this way of doing things keeps the starts of the seasons as close to the solstices and equinoxes as possible. The eccentricity of the Earth's orbit means that the time between the June solstice and the September equinox is slightly longer than the duration between any other solstice and equinox, or equinox and solstice. Okay, well, writing this, I realized that I was saying solstice and equinox a lot, and it annoyed me that there isn't a single word that refers to both of these, so I'm going to call them axial days. I think that sounds nice. Anyway, the time between the axial days in June and September is longer than the time between any other axial day in the next. In other words, in the northern hemisphere, summer is the longest season. At least, assuming you define the seasons as starting and ending on the axial days, which I'll get back to that later. The difference is only a few days, but the discrepancy makes it so that the card calendar is actually really close to what you get if you just define the season as starting on the closest Sunday to each axial day, though the particulars of the leap week math in my system stretch the error bar on that by a few days. Regardless, this is the card calendar as I designed it a few years ago. I have a page on my website where you can convert dates between it and the Gregorian calendar or view the card calendar for any year you like. But for what I was saying earlier, I have more I want to say about seasons, but because it's all only loosely related to the card calendar, I'm splitting that out into a separate video, which I will have done in much less time than it took me to finish this one. Because yes, it has been 2 years since the last video, long enough that Venus became the evening star again and people had been looking up what it looks like. But about that video, a few months after I made it, a paper was released that showed that Uranus and Neptune were a lot less blue than everyone had been led to believe, which is somewhat embarrassing for me, because I said, all the other planets look pretty much how you'd expect them to in real color, though perhaps with a bit less saturation. And I said this because I looked through the common images for each of them and checked that they were taken by sensors with red, green, and blue channels, and the Voyager 2 images were, so I trusted that they were accurate. Except, they weren't. This isn't exactly the same situation as with the Venus images. Those were largely inaccurate because they used ultraviolet channels, while for the Uranus and Neptune images it was mostly a matter of gamma correction. The hue was correct, but the contrast was way too high, so yes, it is accurate that these were true color images composed from red, green, and blue channels, but only in the sense that this is a true color image of a cantaloupe. It's an astonishing enough difference that I added a correction in the description. I feel especially embarrassed because my original plan was actually to go through all the planets for the video, but I decided against it for time, and if I had I might have discovered this before anyone else did, which would have been cool, but the end result is the same. The situation has motivated me to double-check Jupiter and Saturn though, as well as their major moons, the results of which I will also publish as its own thing, but For now, here is Saturn and its moon Titan in true color, which is closer to brown than the yellow it's usually depicted as. For now though, my next video will be about seasons.